Hey there, Algebra 1 students. We're looking at systems of equations some more here, and we're going to learn how to solve them with substitution. Substitution is the name of the game today. Substitution right here. And you can ignore this unless you use your online version of your textbook. We're going to stick to using our online resources. So I promised, first of all, this is not my lizard, and second of all, it's actually really easy to get a domesticated pet lizard to do stuff like this. They're super cute like that. In fact, some of them, when you flip them upside down, it kind of messes their equilibrium up and they fall asleep. It doesn't hurt them. It's just kind of funny. But poor Izzy, not apparently doing so hot there with the algebra. So we are, though, we're going gangbusters. We're jumping right into substitution for systems of equations. Okay, when we solve a system algebraically, we do it by working the math out on paper. And there are two ways to solve a system algebraically. One is called substitution, the other one's called elimination. And we're going to deal with substitution in this video. Substitution is where one equation is substituted into the other one. And what it does is it allows us to get down to an equation with one variable, solve for that variable, and then we substitute again and find the other one, and we get an ordered pair at the end. To solve a system with the substitution method, number one, you're going to solve one of the equations for one of the variables. Now, that may already be done for you, as is in this case, or you may have to actually solve for y or solve for x, as in a different example that we'll look at in a minute. Substitute the expression for the variable into the other equation and solve. So now that we have this one solved for y is equal to 3x. We're going to take that 3x and we're going to plug it into this other equation where the y is. So that means instead of x plus y equals negative 32, we're going to have x plus 3x. If if y and 3x are equal, if x and 3y are equal here, y and 3x, not x and 3y, 3x and y. If these are equal, one can replace the other anywhere you see it. So if I saw a 3x somewhere, I could replace it with a y. But in this case, I'm going to replace that y with the 3x. And now, it gives me an equation with only one variable in it. And that one variable is an x. So now we're going to combine like terms. Switch back to a pen tool here. 4x equals negative 32. We're going to divide by 4. X equals negative 8. So remember that the solution to a system of equations is an ordered pair. So I now have the x value of my ordered pair. I need the y value of my ordered pair. So we're going to take that x value and substitute that solution into one of the two equations and solve for the other variable. Since I already have the x, I'm going to use the equation that's already written y equals 3x. And I'm going to replace my x with the negative 8, giving me a y value of negative 24. And there's your ordered pair solution for the system of equations. Now, if I had a graphing calculator, I might go ahead and solve this second equation for y, graph them, and see this solution on my screen. And yes, of course, as usual, I will show you the calculator way for finding these answers. But to check it, the best thing to do is to go back to the beginning of the problem and to plug the numbers in from the ordered pair to both of the equations. So I'll do that real quick. I'll use green. Is negative 24 equal to 3 times negative 8? Yes, it is. And is negative 8 plus negative 24, is that equal to negative 32? Yes, it is. So I've checked them by plugging them in. I know my solution of negative 8, negative 24 is correct. Let's try another one. Okay, on this one, you have y equals 2x plus 7 and y equals x plus 1. Now you already have an equation, in fact, both equations that are solved for y. So you can take and plug one into the other. So in other words, I'm taking the two x sides of the equation and setting them equal to one another. Setting them equal to one another, giving me an equation that I can now solve. So I'll subtract x from each side, giving me x plus 7 equals 1. Subtract 7 from each side, giving me x equals negative 6. Now go back, plug it in to one of the two equations. Plug it in, plug it in. You're going to hear a lot of that in class. Negative 6 for x plus 1 is negative 5. So now I have my solution. I have x equals negative 6 and y equals negative 5. And I'm going to write it as an ordered pair. Negative 6, negative 5. And then I'll go ahead and I'll check it. So does negative 5 equal 2 times negative 6 plus 7? I kind of ran out of space there on the side. Well, that's negative 12 plus 7, which is indeed negative 5. So I know that one's right. Take my other equation. Is negative 5 for y equal to negative 6 for x plus 1? Yes, that's also equal. I checked my answers, my solution, and I got my answer. Okay, let's do another one that has one solution. Now this one, not ready for substitution. Almost ready for the thing we are going to learn next, which is called elimination, but not ready for substitution. So, no big deal. We're going to take this equation and we're going to look for the easiest variable to solve for. So what I want you to think about here is that you want to look for 1x or 1y. If you have 1x or 1y, then substitution is going to be a good idea, and we do in fact have 1x. Or 1y, excuse me, right here. So we're going to solve for that y, and we're going to do that by adding 2x to each side. That means y equals, think logically here, negative 3 plus 2x. Nah, let's do 2x minus 3. Same thing, just more reasonably stated. Now that we have that, we're ready to substitute, because if y equals 2x minus 3, I can replace this y with a 2x minus 3. And there you go. So we add 3 times the quantity, 2x minus 3, plus 4x equals 14. We're going to distribute. We're going to combine like terms. We're going to add 9 to each side. Sorry for the delay there. I had to pause it. A little bit of an editing jump. I apologize. We're going to divide by 10, and x is equal to 2 3/10, or 2.3. Now we're going to go back. We're going to plug that in to find y. Now be practical here. Y equals 2 times, plug in your x, and there you go. And that way you don't have to worry so much about which equation am I going to use, which equation am I going to use. It really doesn't matter which one you use. You can use this first one if you wanted. You could use this one. But if I'm trying to find the y, the most logical one that makes the best sense for us to use is this one, because y is already alone. I just have to do the math on the right-hand side, and I have my answer. So 2 times 2.3 is 4.6, minus 3 is 1.6. So my ordered pair for this one is 2.3, 1.6. Now, I'm not going to go through checking that one. I did check it myself already to make sure I had it right, but I'm not going to go through writing out to check it. You can always do that part on your own later. And with a graphing calculator, that's actually pretty fast. So that takes care of all the ones with one solution. Let's look at what happens when you have infinitely many solutions. So recall just for a second here, you have 3 possibilities when you have 2 lines on a coordinate plane. You have 2 lines that cross, that's one solution. You have 2 lines that are parallel, that's no solution. And then you have 2 lines that it turns out are actually the same line twice, and that's infinitely many solutions. And that's what we're going to have with this example. So what we can't tell right now is that these 2 equations are actually exactly the same equation. And we know that only because I'm telling you right now, or we could know that if we were to solve this equation for x. Now, we're not going to do that. We're going to go ahead and just do the substitution. If x equals negative 2y plus 4, that's what we're going to replace x with. So 3.5, replacing the x with the expression negative 2y plus 4 plus 7y equals 14. We're going to distribute. 3.5 times 2 is 7, so 3.5 times negative 2 is going to be negative 7y, plus 3.5 times 4 is 14, plus 7y equals 14. And this should cancel. The negative 7y and 7y, that cancels. It should start looking like something weird is happening. Well, that's true. And that true automatically leads me to say that this system has infinitely many solutions. Infinitely many solutions. So when you get that true statement, That's an indication of infinitely many. And again, if I was to go through and solve this second equation for x, I would get exactly this. And you can't always see that from the equations. So being able to write it out like that algebraically and see that result, that's what we're doing. Okay, let's do another. So that one was infinitely many. This one is a no solution one. And again, it's already solved for y. We already have it ready to go. This one's already got the y there. We're going to put it right there for y. So we're going to replace the y with a 3x minus 11 minus 3x equals negative 13. 3x minus 11 is in parentheses only because I replaced the y with it. I don't need those parentheses. They don't actually do anything. Just sort of a way just a notation. It's just the way we write it. 3x minus 3x cancels. We get negative 11 equals negative 13. Well, no, it doesn't. That is just patently false. Not true at all. Not true at all. And a false statement at the end of solving indicates that we have no solution at all. Now, what I can also point out here is that if I was to solve this second equation right here for y, this one right here, I would get y equals 3x minus 13. Well, look, 3x minus 13 and the first one was y equals 3x minus 11. Now, we actually already saw that. Same slope as parallel lines. So same slope. Oh, I know. That means these lines are parallel, which means they won't cross, which means the system has to have no solution. Okay, so sometimes you're going to see it ahead of time and sometimes you're not. Last one is an application problem. A snack bar sells 2 sizes of snack packs. A large snack pack is $5 and a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? Well, first of all, we need variables. So we are going to write equations for this. We are going to choose 2 variables. Let's use x to represent number of large snack packs, and y will represent the number of small snack packs. Now, we know the total. We know they sold 60. So x plus y must equal 60. We also know the total money they spent. The total money they made, 200, no, not 225, just 220. 220. And we know that $5 times large snack packs plus $3 times small snack packs equals the money. And in an application problem like this, you are often going to have one equation that has to do with the number of items and another equation that has to do with the cost, the dollar amounts of those items. So we're going to solve this by substitution, which means taking that first equation and solving for x or y. I'm going to solve for, we want to find the number of small snack packs, right? Which is y. I'm going to solve for x. So x plus y equals 60. Subtract y from each side. And I have something I can plug in for x. Now, why did I choose to solve for x instead of for y? Well, look what happens when I plug it in. So I'm taking my second equation, and we're saying if x equals negative y plus 60, which it does, because x plus y equals 60, then I can substitute negative y plus 60 in here for x. Now, why did I choose to solve for x and not y? My equation now only has a y in it, and that's actually what they wanted in my answer. That's what they wanted me to find. I am completely out of space. That's what they wanted me to find was y, the number of small snack packs they sold, and that's what we made y represent. So let's combine like terms. I have negative, hey, big old mistake. How many of you paused it and emailed me before you let me continue, huh? 300. Oof. Okay, I was wondering why it was trying to come out negative. Combine like terms, negative 5y and 3y is negative 2y. Subtract the 300 from each side is negative 80. So y equals 40. Dividing both sides by negative 2, y equals 40. All right, so 40 small snack packs is my answer. 40 small. But you know what? I didn't actually check my answer. let's check my answer. If there were 40 small, there had to be 20 large. If that's the case, let's check the money situation. 5 times 20 and 3 times 40. That's the money they should have made off of them. 5 times the large snack packs, 3 times the small snack packs. That's 80. No. Wow. Let's try that again. That's 100 plus 120, which is 220. We definitely got it right. 40 small snack packs were sold. All right, guys, that's substitution. Start practicing with this skill, and I'll see you in class.